game. In this part we're going to create some enemies that our player will have to avoid. Let's start off by hiding our UI so we can have a better look at our game scene. We're first going to start by creating a patrolling enemy. It's going to be a flying monster that flies around between 4 points and the player has to avoid it. Let's start by creating an empty object. Let's call it enemy parent, as we're going to separate it into 2 separate sections. We're going to create 2 sub-objects. One's going to be patrol points, and the other one is going to be the enemy. We're separating them because when the enemy would move, the points would move with them, and then the enemy would never reach the point. Next, let's create a sprite that will be underneath our enemy. We're going to call this sprite. We can go to our sprites folder, sprite sheets, and then where we selected our player, we can choose one of the enemies. I'm going to be working with the flying character. There he is. And we can start by giving this enemy an animation set. Let's go to our animation folder. Let's create a new animator. We'll call it flying enemy. We'll attach it to our enemy. Animator. We'll attach it, and then we'll go to our animation window. We're going to create a clip called flying enemy. The clip will be very simple. We're just going to switch between the different sprites. Let's go to 10 seconds. Let's go to the next sprite. Let's go to 20 seconds. Let's go to the next. Let's go to 30. Let's reverse it. Let's go to 40 and have our initial sprite. Let's test it out. This looks pretty good. We can now start adding extra stuff to our enemy. First, let's add a box collider. 2D. Let's make sure that we can view it. Let's make the background disappear so we can have better visuals. We're gonna make the box collider small so that the player has some leniency when they get touched by the enemy. We're gonna make sure that the box collider is a triggerable collider, and we're gonna set the tag to be death. With that, our player will be able to die upon touching the enemy. And now we'll have to create a script that controls the enemy. Let's go to scripts. Let's create a new script called flying enemy controller. Let's attach it to the enemy object. And let's edit it. We're going to start by creating an array. Array is a collection of data, and we're able to connect the points to this data. So let's do public transform. We're going to define that it's an array using these brackets, and we're going to call it patrol points. Let's take a look at what it looks like in our scene. As you can see, currently our list is empty. We're going to set it to be 4 points at the moment, and then we'll need the 4 transforms for the enemy to fly between. We're going to create those in here. Let's create a new object. This is going to be point 1. We'll give it a dot so we can view it. And then let's move the position to be 1, 1. So it's in that corner. Then let's make another one, point 2. Let's move this one to be -1. Let's change the color so we can tell that it's a different one. Let's make one more, point 3. This one will be -1, -1. And let's make a point 0 that starts in the top left. This one's going to be -1. And let's change the colors of them just so we can tell which one is which. Now you don't need to make a square shape for your enemy to control. It can be any shape you like. You can actually move these points in any shape you want. What we're gonna do is have the enemy fly between this point to this point. The only thing is they will fly in a straight line. So we're gonna keep it as a square for now. Now that we have these points, let's connect them here. And let's go back to our code to provide the enemy with movement for these. First thing we're gonna do is create a private integer with patrol index. It's gonna be set to 0. We'll use this variable to keep track of which point the enemy is currently going towards. In our update function, we will update the transform position of our enemy. So we're gonna do transform that position is equal to vector2 that move towards. This method will allow us to move between the 2 points in small increments so that the enemy doesn't just teleport from one point to the other. To do so, we're going to have to give it its current transform and placement. We're going to have to give it the current location we're going towards. So we're going to do patrol points. Patrol index, so currently where we're looking at. Patrol index, so if our patrol index is 0, that would be us looking at the point 0 in the Unity, and then we have to get the position from there. Lastly, we need to give it speed, so let's create a new public variable. Public is going to be a float, public float, and we're going to call it speed. Let's initialize it to be 5 for now. We'll test it as we go. So we're going to do speed times time, that delta time. We're going to use time delta time to standardize the speed so it moves in small increments rather than 5 units at a time. Let's place our enemy somewhere within our view. So as we saw, the enemy instantly went to the point 1. However, we don't have any functionality to go to the other points, so we'll have to implement that now. So let's create an if statement. If the transform that position is equal to the transform position here, we're going to increase the patrol index, and we'll have to check if the patrol index goes outside. So currently we have 4 points. We start at 0, we go 1, 2, 3. If it went to 4, we will get a bug, so we need to rotate back to the 0. So just as Visual Studio suggests, we're going to do this. As we can see, the enemy moves between the points. The enemy moves rather quickly between the points. So what we can do is create a pause effect every time an enemy reaches a point. So they stay there for a second, allowing the player to perform an action. Let's go to our code and do that. I'm going to create 2 variables. One is going to be a public, be float, and we're going to call it wait time. And this is how long the enemy is going to wait at a point. And then we're going to create private float current time. This is going to be how much time has passed, and we're going to always count down this value. In case that the current time and wait time are different, we should initialize the wait time at the beginning. Whatever you change the inspector wait time to be, the current time will also start with that. Next, we gotta go in here. We're gonna check if the current time is less than 0. If so, then we're gonna perform all the actions we did. That means the player has stopped waiting. Otherwise, we're going to count down the current time. We're gonna do minus time that delta time, and this will allow us to count down how long it will be. One thing we have to do is reset our current time to wait time at the end of each of these setups. Now, one thing we have to account for is that we don't want this timer to be occurring while the player is moving between points. So we're gonna take out this if statement here. Oh, it's not true, so the position is not equal to the current goal. We just turn. We no longer have to check if the position is in place because we checked that already before getting here. Let's go through this one more time because there was a lot happening here. When our enemy spawns in, they will move towards the first point. As long as they are not at that point, we don't do anything. Once we reach that point, we will create a countdown timer. If the timer is bigger than 0, we will subtract from the counter. If the counter is less than 0, we're gonna move to the next point. If the point is bigger than our length, we're gonna reset it, and then we're also gonna reset the current timer so that next time around the enemy also waits the same amount of time. Let's test it out. The enemy performs the actions as we wanted. The only issue might be that the enemy starts at our central location. We might want them to start at the first point. So let's go into our code and change that. Let's make sure that the transform.position is equal to the current index, which is 0. This way, our enemy will always spawn at that central position. Now that we have our enemy spawn at our index position, we could make our patrol index. We can make it public. That way, we can edit it in the inspector and have different enemies spawn at different locations. With that, we have our first enemy. Let's make sure that we save them as a prefab so we can create multiple copies of them. I'm going to create a couple copies of our enemy. We're going to place them side by side. And now we can actually go into all of their inspectors and adjust them. So we can say that the first enemy will spawn at 0, he will move at 5, and he will wait for 1. But we can also go into our second enemy. We can make them move at 2.5, stay at the points for 0.5, and start at 0.2. Looking at our last enemy, we could even adjust the path that the enemy travels, so we can adjust 1 point. Let's put this one in here, and then we can have him start at 0.1. And we'll make him move much faster than the others. We may have created one enemy prefab, but with the power of the inspector, we can actually adjust our enemies in different ways to have them have different behaviors and different speeds to create different challenges for the enemy, even though we only have one type of enemy currently. And we'll move on to the next enemy. So let's start creating our second enemy. We'll start the same way as before by creating an empty object. We can call this one walking enemy. This one we will not have to separate the enemy from its points, but we will have several children underneath it. Let's start with the first one, which is going to be the sprite. Let's create a 2D sprite. Let's call it sprite. Let's go to our sprites. Let's go to our sprite sheet, and then let's choose one of these. I'm gonna go for our little red guy here. Let's connect them. And like before, we're gonna create an animation for him first. Let's create an animation controller. Walking enemy. Let's attach the component. Animator. We're going to connect our animation controller, go to our animation window, and create a clip. We're going to call it walking enemy. And like before, we're just going to change the sprites. Let's go to 10 seconds. Change it to this one. Let's go to 20 seconds. Change it back to the original and see how it looks. That animation looks fine. We can continue creating our enemy. What we'll do is add a collider to our enemy. Now this collider will be used to see if the enemy is touching anything. So we're going to squish the collider to only take a part of its body. We're going to keep one end a little bit inside while the other one extends. This will be to check if the enemy is touching any walls. This bit in front will be our direction that the enemy is facing. So let's flip the sprite to face such. Let's also make sure that it's simple. We're going to be flipping this game object left and right whenever we check if something is touched. Unlike our flying enemy, we will give this one a rigid body. We don't want this guy to be hanging out in the air. However, we do need to edit some values. We're going to freeze its rotation. We don't want the collider to ever tip over and start rotating. We want him to always stay horizontal. One last thing we're going to do is create a second collider and a child object. We're going to call this body collider. And we're going to create a collider for it. Now this is what is actually going to be holding up our enemy. This way his feet are always touching the ground. Meanwhile, this collider is detecting any touches of the walls. We will add one last collider. It's going to be a polygonal collider. And we're going to shape it to the body of the enemy such that if a player encounters them, they will trigger and kill the player. Let's make sure that this is set to trigger and that our enemy is tagged as death. With these three colliders, we'll be able to have our enemy stand, touch against walls, and make sure that they kill the player if the player encounters them. Now let's create a script that will actually accommodate that. Let's call it walking enemy controller. Okay, so first thing we're going to do is get our rigid body so we can control the velocity of our enemy. Okay, next thing we want to do is we want to update our velocity by a speed, so we will also want to give our enemy some kind of speed. Rigid body, that velocity equals new vector 2. We're going to speed comma rigid body velocity y. That way we can adjust how fast the enemy is going left and right, meanwhile keeping the y velocity as intended by the body. Next we're going to create a collision function. So we're going to do private void on collision enter 2D. So this checks if the body, this rectangular one in the middle, comes in contact with anything. If it does, we will change the direction the enemy is walking in. So to do that, we will need another variable. We're going to call it private int direction, and it's going to be equal to 1. 1 means that the enemy is moving in a positive direction. -1 will mean that the enemy is moving in the negative direction or left. So we will modify our speed given that direction. And here upon collision, we will actually change the direction. So direction, it will be times equal -1. So anytime the enemy encounters something they touch, the direction will switch. Let's save and test it. Let's connect the script to our enemy. Let's place our enemy on the ground. For now, let's turn off the death tag just to see if when the enemy touches the player, they'll turn around, and then we can test it against the wall as well. So as you saw, now the enemy touches the player, then they touch the wall, and they walk back and forth. One thing to note is that the enemy didn't turn around, so we will have to mitigate that. But before that, let's add the death tag back. We can change the direction the enemy is facing by doing transform, that's scale, equals new vector, and it's going to be direction, comma 1, comma 1. So whichever direction the enemy is facing, that's the direction that the scale will also. Now let's test it out with one more possibility. Let's say we want to have enemies on floating platforms or little edges. Will they be able to stay on the edge, or will they fall off? So right now the enemy will just jump off a ledge. That could work in some situations. However, as you saw, he will also jump into the water and stay on the bottom of it. What we want to do is create an enemy that will always stay within their designated area. So they will be tracking the floor, and if the floor disappears, they will switch directions and walk the other way. To do that, we will use some of our jumping code. We will take our capsule. We will also take the ground check components. And lastly, we will also take the ground check itself. With this, we will be able to check if the ground runs out by creating an if statement. We're going to check if there is no ground, and if so, we will perform these actions. Now let's check this in our inspector. Now, like with our player, we will have to give this a feet collider. So we'll create an object, we'll call it feet. We will give it an image so we can see what it looks like. We would like the collider to be somewhere around its feet on the side that it's going to be checking. So let's move it here, 0.5 by minus 0.5. And let's make sure to connect stuff. We're going to connect our feet collider, and we're going to make sure that we're checking for ground. Let's try it out. As you can see, we have a little enemy that can hang out in a small space, and they can also walk around in larger areas, bouncing off walls. This will create a great obstacle for the players. Let's do one more thing before we finish this and create a prefab of it. With these two enemies in our game, we'll be able to create many great levels. Thus, we'll end this part of the video. In the next one, we will talk about designing levels and create an exe file that you can export and give to friends and family to try